Thank you, everyone. So this talk, just before I start, please bear in mind that I'm compressing the past around 40 years of research in 15 minutes. So don't take it personally if your paper is not there, because it's like a lot of papers that I'm compressing here. So I'm selecting the most relevant ones, just so you can understand like the principle of functioning of the different approaches. All right, so multi-user displays, collaborative work nowadays, it's something that is really important. Normally we work as groups, and perspective correctness is something that is really, really important, because sometimes when I point in a virtual reality space, in here, if I have the perspective correctness on a cave system, for example, the user that is next to me will not see me pointing to the same position from his perspective, because he doesn't have a correct perspective view. And it's backed up by Pollock. He backs up this idea saying that collaboration processes get delayed because of not corrective perspective views for everything. So Mark Bolas, on one of his papers, he introduces 4 categories for producing multi-user VR displays. We think that volumetric displays and lightfield displays are also worth adding to these categories, and we're gonna discuss them. So spatial barriers. So the spatial barriers is one of the approaches, and they use the display physical configuration in advantage to separate users. For example, Sandin's barrier system, he uses parallax barriers to separate users, and they do camera tracking to track where each of the persons are. The PIT, or the Protein Interactive Theater, you can see here that they angle screens at 90 degrees. So with these, they manage to pinpoint with exactitude in the space parts of a molecule or something in 3D. Now, depending on the approach used with spatial barriers, brightness is reduced normally, and resolution is affected, of course, because you are multiplex. You only have so much resolution on your screen, right? Other projects that use this approach is, for example, the AV project. This one is basically a VR theater with a 360-degree skin with omni-stereo at the center. So if you're at the center here, you have a perspective correct view. The illusion hall, which is a normal display, and they have a mask where different viewers can see different parts of the screen, and the object is generated here. The roundel hole display, they use the same principle. They use a mask with a Poisson disk distribution, and with this, they can separate users. Also, Mark Back, he uses image blending for rendering different users' positions depending on where they are looking on the screen. And when they get together, he just blends the image. Again, there are like lots of work regarding spatial barriers, but these are some like of the principles of work. Well, let's talk about optical routing. So this approach uses angle-sensitive characteristics to route or deflect the light to multiplex imagery. One of the examples is, for example, Little and his team. He uses multi-perspective. He proposes a multi-perspective stereoscopic display. He uses LCTVs that project images to a pupil-forming screen, and the screen is fabricated by either a holographic element or Fresnel lens and 2 cross-lenticular lenses to produce stereo. They use slanted lenses to reduce the picket fence effect. On the other side, Asian Love, I'm sorry if I pronounce it incorrect, he proposes a hybrid time multiplex optical routing approach. We will talk about time multiplex a little bit later. And he produces a system, or he creates a system with 8 views. They reduce the bright light that illuminates a fast LCD, where the images get magnified and projected to a beam steering system to sequence views, as you can see here. And also the synthogram by Lipton consists of an LCD with slanted lenticular lenses that help reduce the moire patterns. Now, this approach, color banding is one of the issues. Loss of resolutions, of course, because you only have as much pixels on the screen. And ghosting are some of the challenges of this approach. Other interesting papers that have appeared across the years is Nguyen et al. Here they present a special display that consists of a screen with three layers with directional reflection, so each participant sees a customized image from their perspective. The free-to-see display here, it's a single viewer autostereoscopic display with head tracker. The display readjusts the lenticular lenses with the head movement, and the range goes from 40 to 110 centimeters. This Kim, he has an interesting approach, and he exploits the twisted nematic properties of LCD panels by controlling the contrast. So from one side, you can see an image, and if you move your head to another side, you can see another image. So that's a quite interesting approach. Zhang, on the other hand, he uses a frontal multiprojector approach. They use 8 projectors and a 3D image guided screen and a lenticular lens with a retroreflective screen. Finally, Jones, he uses 216 projectors closely spaced from each other to project to an anisotropic light shaping diffuser to generate a 3D image. Well, let's talk about the optical filtering approach. So this approach involves a system that filters viewpoint using light electromagnetic properties. For example, this Delaray and his team, he combines anaglyph filters with shutter glasses to produce stereo and separate users. Schmidt, on the other hand, he uses a wavelength selective filter arrays. It's like a filter that tightly matches pixels on the screen to separate users. York and the Infitech system, they basically use this system called the Infitech, which is interference filters. And with this, they multiplex images in different spectral ranges by using a narrower wavelength band to increase the number of images that can be shown in parallel. Other approaches that I think they're worth noting are the scritter. It's basically they enable a superimposition of subtitles while sharing a movie using circular polarization filters. That's pretty basic. So Kim also, he proposes a system capable of displaying full-colored stereoscopic images with anaglyph filters using an anaglyph filter, and by switching the colors, they can produce a full-colored image with anaglyph approach. And finally, LiftFast, they work on on a similar project based on Scritter for a karaoke machine to hide menus on the karaoke for some users and show the menus to other ones. So time multiplex. So time multiplex is a quite interesting approach, and most of the work is cites Agrawala's work. In Agrawala's work, they basically present a two-user responsive workbench, and what it does is that it allows two persons to use to see separate stereo images. They don't lose resolution, but brightness is affected because at some point in time you don't see anything. You're fully shuttered, and then the other person sees, and then the next time you see, but the other person doesn't. The Cambridge display by Dodgson, I have problem pronouncing that. It's a high-speed display with a Fresnel lens and a series of abutting bar-shaped light sources that with time multiplex, they show different images. And finally, Frolic, he introduces this system that with shutter projectors to support several users, but they use two projectors per person. They use a highly customized circuitry to do this project. Another approach by Liu and his team, they use directional backlighting to selectively light certain portions of the screen and display different images through time multiplexing. Kotaki, he uses DLP projectors, but they don't use a complete shutter approach. So they use a grayscale shuttering to use image decomposition to reduce flickering, because that's one of the issues with time multiplex. The issue is that they have to bake the imagery. So they don't support real-time images. And another more peculiar system is by Barnum. So they basically use a single projector with layered displays with water drops. And with time multiplex, they send light and are able to color these displays differently. For example, they are playing, like, I guess, a 3-player Tetris here. Now let's talk about volumetric displays. Favalora, one of his projects was a volumetric display, and he basically produces imagery with a rotating screen by sequencing rapidly 2D image slices. I was quite amazed to meet him in this conference, because a lot of people here, I have read your papers, and I feel really humbled to be able to meet a lot of you. Sullivan, he uses a DLP projector to render slices of a 3D scene into a stack of liquid crystal scattering shutters. And Jones, he uses high-speed wide projector on a spinning mirror covered by a holographic diffuser and an FPGA to generate imagery. Other approaches are, for example, Otsuka. He presents the transpost system, and they project into a spinning directional reflection screen with limited viewing angle, as you can see here. Eitoku also has a peculiar system that uses water drops, again, and they produce the images by using tomographic approach. Finally, and this is dangerous also, Kimura uses a laser plasma technology to create flashpoints in the air by controlling the focal point and direction of where the laser points. One of the problems with the volumetric approach is that you cannot pinpoint inside normally the screen. Lightfield displays, Weinstein, for example, in his approach, he uses static images with tomographic techniques for rendering high-resolution volumetric frames. Landman, they stack a set of LCD panels with single pair of crossed linear polarizers. With this approach, they managed to produce imagery at 24 frames per second. Also, Weinstein, he introduces tensor displays, which consist of a single backlight with a layered display with lenses in between. And Maimon manages to increase the area, the view in the field of view of light field displays by using a Kinect. Now, which approach is better? It depends. There's no clear winner. It depends on what you need, what you're using, what you want. Hybrid approaches try to exploit the best of each world, but again, it depends. Parallax methods, optical routing approaches, they have their challenges, but there are also a lot of research going on, and mainly the main research from what I have seen is focused on light field displays. So that's pretty much. Thank you so much, and now I'm open for questions.